All right, here's a quick tutorial about how to do the ballistic pendulum lab. What ultimately is happening here, looking at this in two different situations, because this is a multi-step problem. Let me change the difference between a hard problem or an easy problem in physics is a hard problem. It's just a series of easy things you got to kind of put together. So the first part of the problem, the little ball is flying in. It's going to hit the pendulum. And what we're going to have here is a collision. The two are going to crash. And in collisions, we're talking momentum. So that's why the momentum equation is here. P1 plus P2 equals P1 prime plus P2 prime. So that's the momentum of the ball and the pendulum before the collision equals the momentum of the ball and the pendulum after the collision. So that's what's going on here. Then here, the ball has hit the pendulum and now it's swinging back and forth and you have a pendulum in motion. We did pendulums in motion in the last section, which was energy. So for here, we know that the energy is going to be conserved as this thing swings back and forth and back and forth. So when it first gets hit right here, it's going to start moving. So we know that's going to have some kinetic energy. It's going to swing way up here at the highest point. We know it's going to have a whole bunch of potential energy, but the total energy is conserved. The kinetic and potential will go back and forth and back and forth. Kinetic will be high when it's really low, and then it's going to drop as potential goes up as it swings up until it stops moving upward and starts coming back down. So this equation would simplify right here. If I'm looking at this as my left side of the equation, I know it's going to have kinetic energy. So that's fine, but it's not going to have any potential energy because it's as low as we care about it. Right here, it's at its maximum height, so it is not moving anymore, but now it's raised up, so it is going to have some potential energy, no kinetic. So kinetic energy, 1/2 mv squared, is going to equal potential energy mgh. Well, okay, so what the heck are we doing here? What we're going to be doing here is, since we're looking for something at the beginning of the problem, we're going to start at the end where we know a bunch of stuff. The problem gave us the angle. We know the masses of everything. We know that it's swinging back and forth. So we're going to find out some information here and work our way back to the beginning. Well, what does here have in common with over there? Well, the speed of the pendulum at the very bottom is the speed it has right after it gets hit. So if I can find the speed of the pendulum at this lowest point, what I've got is the speed after the collision. So that's what they have in common. So if I go over here, solve for the velocity at the lowest point, I'm able to use that over in the momentum and conservation of momentum and solve for the velocity of the ball at the very beginning. We will need to solve for height here. You might notice that in this little picture, I have a bit of a triangle. I have an angle. I have my pendulum here. My pendulum is here. It's going to swing over to this side. Now you're given the length of the pendulum. What are you given the length of the pendulum for? You're given the length of the pendulum so that you can solve for the height. Because I don't know what the length of the pendulum will be for you because it changes up every time. But just for easy numbers, we'll just say it's 2. The length of the pendulum is 2. That's how long that is, which means that this distance is also 2 because that's still the pendulum. So how do we solve for the height? Well, you have a triangle here. You have an angle. You have a hypotenuse. You're able to solve for either the opposite side or the adjacent side. Adjacent side would be what we're looking for. So if I'm able to solve for the adjacent side and I say, oh, the adjacent side there is 1.5. I solve for it with my angle. I know my hypotenuse is 2. I solve for this is 1.5. Well, then what's this have to be? That's got to be a half because 1.5 plus a half gives me my 2 that I was talking about. So that's how you would solve for the height. So a little bit of geometry to solve for the height. That's going to let you do the conservation of energy, which is going to let you come back over here and do the conservation of momentum to solve for the velocity of the ball. Don't forget that you're going to need to convert. I believe they give you the length of the pendulum in centimeters. So that means move the decimal 2 times to the left to get meters. And they give you the mass of the ball in grams. Move the decimal 3 times to the left to get kilograms. If you don't convert, you will continuously get wrong answers. So please make sure you convert your answers correctly. If you have any questions, reach out.